Hey learners, so let's start with a simple but powerful idea here. Object relationships in OOP. Basically, we will be understanding these three concepts here: association, aggregation, and composition. These are few common interview questions because surprises are better at portrays, not in interviews. They might ask difference between association, aggregation, and composition. And some real life example questions also they might ask. Or maybe how would you model a relationship between a driver and a rider in a Uber ride sharing system? Other question maybe from your project related like why did you model it in this manner or something like that. We'll discuss them all. So what exactly is object relationship in O? If I say in formal definition, it is object relationships define how two or more classes or objects interact with or depends on each other. These relationships allow objects to collaborate to perform tasks and form the structure of a software system. Let's jump into two cool real life examples. First up, a teaches a student. You have got two classes here, teacher and student. They know each other, but one doesn't own the other. A teacher can teach without a specific student and vice versa. In a school software, though, we want to link them, like Mr. Sharma teaches Aman. The second example here, a car has an engine. Can the car exist without an engine? No way. The engine is a part of the car. It lives and dies with it. The relationship is deeper, more connected. It's like organ in a body. So why do we even care about the relationship between classes or objects? Because these relationships help us design smarter code. Ask yourself, do these two objects know each other? Are they part of each other? Can one live without the other? These are the questions we'll be exploring in this video. Alright, so time for our first relationship type, association. This is when one object knows another, but they are still totally independent. Think of two people who know each other. The example we saw earlier, like a teacher and a student. Neither owns the other, but the teacher teaches the student. They are connected for a purpose, but they can live separately. Other examples of association. A doctor treats a patient. A customer talks to a support agent. A user logs into an app. Let's see this code snippet. Student class definition. We define a student class. It has one attribute name and a constructor which sets the name. Then we have a teacher class here. Teacher has its own name and a reference to a student. This shows association here. Teacher uses student but doesn't own or create it. Then there's a constructor injection in the teacher's class. The teacher object receives a student object externally. It does not create the student internally. This is classic association. And there's teaching method. Teacher uses the associated student to perform an action. The relationship is visible during the method execution, but the student is still a separate entity. And now we have main method. A student is created independently. A teacher is created independently and the student's object is passed through it. A teacher teaches the student. Interaction without ownership. So we first create a student named Aman. Then we create a teacher named Mr. Sharma and pass Aman as the student. When teach method runs, it says Mr. Sharma teaching Aman. That's association. The teacher knows the student, but neither one owns or creates the other. They just collaborate. Now time to level up. Let's talk about aggregation. Aggregation is a relationship where one object is a part of another, but can still exist independently. It's called a hazard relationship and it's a weaker form of ownership. Imagine a team and players. A team has players, but players can also exist without the team. They can switch teams, retire, or join another one. So the team uses the player but does not own the player's life. Other real world examples of aggregation can be a library has books, a company has employees, but books can be moved to another library and employees can join another company. So they are weaker form of ownership. Let's see this simple code snippet. We have a book class with a title property, The book is an independent object here. Then there's library class, and we can see aggregation. Library has a reference to a book, but the library doesn't create the book, it only accepts and uses one. Then there's constructor injection. The library class gets a book object from outside. This shows aggregation. Library has a book but doesn't own it. Then there's method to display book information. Library uses the book reference to perform some operation. Now we have main method. First we create a book called Harry Potter. Then we pass that book into a new library. The library displays library has Harry Potter. Now here's the key. Even if the library gets destroyed, the book object still exists in the memory. This means a book is not tightly owned, it's aggregated. That's aggregation. The has a relationship where the child can survive without the parent. Now brace yourself. We are going deep with composition. This is when one object fully owns another. No escape, no survival on its own. Think human heart. You don't take your heart out and say you are on your own. Now, if the human goes, the heart goes. And that's composition for you. Tightest possible relationship. Let us see this through a code snippet. We have got a heart class with a single property type. Now see the magic happening in human class. Notice how the heart is created inside the human, not passed in from outside. It's born as a part of the human object. So when a human is created, the heart is automatically created too. And the show method prints that the human has healthy heart. And if the human object is deleted, the heart goes with it. No reuse, no reassignment. That's composition. Strong, full ownership, no independence for the part. Alright, students, time to compare our relationship trio. Think of them like types of friendships. Association, just buddies. Hang out but live separately. Aggregation, roommates live together but can move out. Composition, conjoined twins, inseparable till the end. Here's your table. Use this as your cheat sheet in interviews, exams, and when designing killer systems. Bring it home how product based companies use these concepts. Like Uber, driver and rider. So the relationship which we see here is association. They meet for a ride, then part ways. Trip and waypoints. We see the relationship aggregation. A trip uses waypoints, but they can exist elsewhere. Now trip and invoice. We can clearly say this is composition. Invoice is tied to the trip. No trip, no invoice. So tech companies might ask questions like, why did you design it in this way? And you can answer this question in this way, like it defines scalability, ownership, data lifecycle, and etc. Alright, rockstars, you're just getting started on your low level design journey. Up next, we'll dive into advanced OOP concepts including interfaces and the game changing solid principles, and that every top tier developer swears by. These are tools that help you build clean, scalable, interview worthy systems, the kind that land you jobs at MAANG and top product based companies. So, if you're serious about becoming a world class software developer, this isn't just a playlist, it's your LLD launchpad. Keep going, stay consistent, and let's master system design together. Hit that subscribe button, smash that bell icon, and buckle up. Because what's coming next is going to blow your tech brain.